Hello everyone, welcome to Principles of Communication System lecture series. This lecture video we are going to discuss about frequency discriminator, FM slope detector and balanced FM slope detector. Previous lecture video we discussed about modulation and generation of FM signal. Now we will look into demodulations of FM signal. The process of recovering the original modulating signal or message signal from the frequency modulated wave is called a frequency demodulation. The frequency demodulation is recovering the original signals from a modulated signal. The frequency discriminator is one of the method to recover the original signals. A frequency discriminator is an FM demodulator which must produce us an output voltage that varies linearly with the input frequencies. That is, it converts the frequency variations into amplitude variation. So frequency discriminator is converts the frequency variations into amplitude variation. A single tuned circuit has the capability to convert an FM signals into an AM signal over a limited range. This type of detection is also known as a slope detection. Slope detector or circuit as a frequency discriminator which implements the frequency to voltage conversion FVC. Output voltage of the slope detector is proportional to the input frequency, for example filters and differentiator circuits. So here this is the differentiator and differentiator input is S of t and this is the differentiator circuit and output is X of t. The X of t is the differentiator output. For example, you take filter circuit and this is the filter circuit and filter circuit input is S of f and filter circuit output is X of f. So for example, you consider one band eliminated filter and this is the characteristic curve. This is the characteristic curve and this is the H of f and this is the frequency. So we know that frequency discriminator is converts the frequency into voltage. So here and this is the frequency line, this is the frequency and this is the frequency variation and this is the amplitude variation and this is the linear curve. For example, so input frequency, for example you take input frequency is equal to 10 Hz, 20 Hz, 30 Hz and 40 Hz. So here for example midpoint is the 20 Hz and this is the 10 Hz and this is the 30 Hz. So here in 10 Hz this is the frequency variation and this is the respective amplitude and 20 Hz and this is the respective amplitude and again this is the 30 Hz and this is the respective amplitude. The frequency range varies from year to year and amplitude it varies from year to year and this is the X of f. This is the output of the filter circuit. X of f is the output variation in terms of voltage from year to year. The given input is frequency and this is the range. It varies from 10 to 30 kilohertz and this is the respective voltage. Let's consider one simple slope detector circuit. The simple slope detector circuit we design using tuning amplifier circuit and envelope detector circuit, and this is the tuning amplifier circuit. The tuning amplifier circuit, it consists of transformer and capacitor, and capacitors are C1 and C2, and this is the envelope detector. The envelope detector circuit consists of diode, capacitor and resistor. The output of the tuning amplifier circuit we connected to envelope detector. So across the resistor we receive the output. So here this is the tuning circuit, this is the amplified, this is the tuning circuit. The tuning circuit input is FM. The main function of the tuning amplifier, it converts the FM signals into AM signal. So here from ear to ear this is the maximum frequency, and ear to ear is the minimum frequency, and again ear to ear is the maximum frequency. So across the C2 capacitor we receive the AM signal. So whenever input frequency is maximum, we receive the maximum amplitude signal. So whenever input is minimum frequency, we receive the minimum amplitude signal. So output of the tuning amplifier circuit we connected to envelope detector. So we know that envelope detector is consists of diode, resistor and capacitor. So here resistor and capacitor we connected in parallel, it acts as a filter. And this is the positive terminal we connected to transformer, and transformer terminal is positive. So diode acts as a forward bias. Diode is in forward bias condition. So it conducts the positive value. The main function of the envelope detector is detect the envelope of the AM signal, and this is the envelope of the AM signal. So across the R1 resistor we receive the AM signal envelope. So this is the envelope of the AM signal. So input is FM signal, and tuning amplifier converts the FM signals into AM signal, and envelope detector, it detects the envelope of the AM signal. So this is the envelope of the AM signal. So this is the filter circuit, and for example this is the output of the filter circuit. So this is the magnitude frequency response transformer of the band pass filter. So this is the frequency variation, this is the carrier frequency, this is the higher value and this is the lower value, and this is the respective voltage variation. So carrier frequency, this is the voltage variation, in lower value this is the voltage, respective voltage for higher value, and this is the respective voltage. From year to year this is the voltage range and this is the frequency range. In simple slope detector there are many limitations. The circuit nonlinearity causes the harmonic distortion. The nonlinearity is obviously from the fact that the slope is not the same at every point on the frequency response characteristic. In other words, the range of the linear slope is very small. The second limitation is a good frequency discriminator should respond only to frequency variation in the input signal and not to amplitude variation in the input signal. In the present context, it responds to a spurious amplitude variation of the input FM wave. The third limitation is the circuit sensitivity is poor, that is change in amplitude for a given change in frequency is small. These are some limitations of simple slope detector. Balanced FM slope detector, it overcomes the drawbacks of simple slope detector. Balanced FM slope detector we design using two slope detector, and this is the slope detector 1 and this is the slope detector 2. The slope detector 1 we design using tuning circuit, amplifier tuning circuit and envelope detector, and this is the tuning circuit, and tuning circuit output so is connected to envelope detector, and this is the envelope detector. It consists of diode D1, resistor R1 and capacitor C1. So this is the slope detector 1, and slope detector 1 output is V0 1. So across the capacitor we receive the slope detector 1 output, and this is the slope detector 2, and this is the tuning circuit, and tuning circuit output we connected to envelope detector. The envelope detector, it consists of diode D2, resistor R2 and capacitor C2. Across the capacitor we receive the slope detector to output. V01 is the slope detector 1 output and V02 is the slope detector 2 output, and actual output voltage is V output, and this is the input of the balanced FM slope detector. So input is FM signal and tuning circuit is converts the FM into AM, and envelope detector it's detect the envelope of the AM signal. So across the slope detector 1 and slope detector 2 we receive the balanced FM slope detector output. The output voltage is V0. As shown in the circuit diagram, the balanced slope detector, it consists of two slope detector circuit, and this is the slope detector 1 and this is the slope detector 2. The input of the transformer as a center tapped secondary, and this is the tap point. This is the transformer 1 and this is the transformer 2, and this is the positive terminal of the transformer 1 and this is the negative terminal of the transformer 1, and again this is the positive terminals of the transformer 2 and this is the negative terminal of the transformer 1. Hence the input voltage to the two slope detectors are 180 degree out of phase. So in balanced FM slope detector there are three tuning circuits. The out of three, the primary is tuned to intermediate frequency, that is carrier frequency. So this is the primary tuning circuit. The upper tuning circuit of the secondary T1 is tuned to above carrier frequency by delta F, that is its resonant frequency is Fc plus delta F. So this is the second tuning circuit. So we designed for upper values. So resulting frequency is equal to Fc plus delta F. So for example, let you assume carrier frequency it's equal to 10 kilohertz, and slope detector 1 tuning circuit output is equal to Fc plus delta F, and we know that Fc is equal to 10 kilohertz. Let assume change of frequency is equal to 5 kilohertz. The resulting tuning frequency it's equal to 10 kilohertz plus 5 kilohertz. The resulting value is equal to 15 kilohertz. The tuning frequency is equal to 15 kilohertz. So tuning circuit 1, so we designed for above values. The lower tuning circuit of the secondary is tuned below carrier frequency by delta F, that is Fc minus delta F, and this is the tuning circuit 2. The resulting frequency is equal to Fc minus delta F. So let us assume F carrier frequency is equal to 10 kilohertz and change of frequency is equal to 5 kilohertz. The resulting frequency or resonance frequency or tuning frequency it's equal to 10 kilohertz minus 5 kilohertz, it's equal to 5 kilohertz. The resulting frequency across the tuning circuit 2 is 5 kilohertz. We have three tuning circuits. The first one, primary, is tuned for intermediate frequency, that is carrier frequency, and second one is Fc plus change of frequency, and third one is Fc minus delta F. V01 and V02 are the two output voltages of the two slope detector. This is the V01. V01 is the slope detector 1 output voltage and V02 is the slope detector 2 output voltage. The final output voltage V0, and this is the final output voltage V0, is obtained by taking the subtraction of the individual output voltages. The individual output voltages are V01 and V02. The final output voltage V0 it's equal to V01 minus V02. Now we will look into working operation of the circuit. The circuit operation can be explained by dividing the input frequencies into three ranges as follows. The case 1, the input frequency F input is equal to carrier frequency Fc. So when the input frequency is the instantaneously equal to Fc, the induced voltage in the T1 winding, and this is the T1 winding of the secondary, is exactly it's equal to the induced in the winding of T2. Thus the input output voltages to both the diodes D1 and D2 will be the same. So this is a diode D1 and this is a diode D2. Therefore the DC output voltages V01 and V02 will also be identical, but they have opposite polarity. Hence the net output voltage V output voltage it's equal to 0. So when F input is equal to Fc, so across the slope detector 1 we receive the same voltage, and across the slope detector 2 we receive the same DC output voltage. So we know that resulting output voltage V output is equal to V01 minus V02. In case 1, V01 is exactly it's equal to V02. The resulting output voltage is equal to 0. In case 2, input frequency is greater than carrier frequency and less than change of frequency. So for example, you take carrier frequency it's equal to 10 kilohertz and change of frequency it's equal to 15 kilohertz. The input frequency in between 10 kilohertz to 15 kilohertz. So in this range of input frequency, the induced voltage in the winding T1 is higher than that induced in T2. Therefore the input to diode D1 is higher than the diode D2. So here diode D1 is higher than the diode D2. Hence the positive output voltage V01 of diode D1 is higher than the negative output V02 of diode D2. So here we get the positive voltage and here we get the negative voltage. So therefore the output voltage V0 is positive. So we know that resulting output voltage V output is equal to V01 minus V02. So V01 is the positive value and V02 is the negative value. So resulting output V0 is the positive voltage. As the input frequency increases towards the Fc plus delta F, is the positive output voltage is increases as shown in this figure. Case 3, input frequency is less than carrier frequency and greater than change of frequency. For example, carrier frequency Fc is equal to 10 kilohertz and change of frequency is equal to 5 kilohertz. The input frequency in between 5 kilohertz to 10 kilohertz. In this range of input frequency, the induced voltage in the winding T2 is higher than that the induced in T1. So T2 voltage is higher than the T1. So therefore the input diode D2 is higher than the D1. So diode D2 is higher than the diode D1. Hence the negative output V02 of diode D2 is higher than the positive output V01 of diode D1. Therefore the output voltage V naught is negative. So we know that resulting output voltage V output is equal to V naught 1 minus V naught 2. In case 3, V naught 2 is greater than V naught, V naught 2 is higher value comparing with the V naught 1. So V naught 2 is the negative voltage and V naught 1 is the positive voltage. The resulting output voltage V naught is negative. As the input frequency is increases towards the Fc minus delta F, the negative output voltage is increases. And this is the characteristic of the balanced slope detector. So vertical line is the output voltage and horizontal is the frequency of input, and this is the carrier frequency, and this is the IR value Fc plus delta F, and this is the lower range is Fc minus delta F, and this is the useful range. When input frequency is exactly it's equal to carrier frequency, the input diode D1 and D2 are equal in this case. So V01 is the slope detector 1 output is equal to slope detector 2 voltage V02. The resulting voltage is 0. So resulting voltage is V01 minus V02. So here V01 is exactly it's equal to V02. The balanced slope detector output is 0. And when input frequency is greater than carrier frequency and less than Fc plus delta F, in this case the input to diode D1 is higher than the input to diode D2. So diode D1 is greater than diode D2. So V01 is greater than V02. So V01 is the higher value, is sign is positive. So resulting output voltage V output is equal to V01 minus V02. So we get the positive output voltage. When input voltage is greater than Fc minus delta F and less than Fc, the input to diode D1 is less than the input to diode D2. So here diode D2 is greater than diode D1. So V01 is less than V02. The resulting voltage it's equal to V output is equal to V01 minus V02. So here V02 is the higher value. So resulting output voltage is negative. If the output frequency is goes outside the range of Fc minus delta F to Fc plus delta F, the output voltage will fall due to the reduction in the tuning circuit response. So Fc minus delta F to Fc plus delta F is the useful range. Out of this range, the output voltage will fall due to the reduction in the tuning circuit responses. Advantages of the balanced FM slope detectors are: this circuit is more efficient than simple slope detector. It has better linearity than the simple slope detector. The main drawbacks of the balanced FM slope detectors are: even though linearity is good, it is not good enough. This circuit is difficult to tune since the three tuner circuits are to be tuned at the different frequencies. The first frequency is carrier frequency Fc, and higher value is higher frequencies are Fc plus delta F and Fc minus delta F. And amplitude limiting is not provided in balanced FM slope detector.
Thank you.